Every single day, millions of people turn on a tap without thinking twice about what's actually coming out. But here's what most of us don't know. The water flowing into your home right now is being tested constantly, and those tests are catching contaminants most people have never even heard of. Water quality testing isn't just some bureaucratic checkbox. It's a sophisticated science that directly determines whether the water you drink, cook with, and bathe in is safe. And the methods used today are more advanced than ever before. So what exactly happens in those daily tests, and what are they actually looking for? Let's start with the basics. Municipal water systems in the United States are required by the EPA to test their water supplies multiple times per day. We're talking hundreds of tests across hundreds of parameters, but most people have no idea what those tests even measure. The most common tests check for bacteria, specifically E. coli and total coliform bacteria. These are the gateway indicators. If bacteria are present in your water supply, it means the system has been compromised somewhere. A single positive result for E. coli triggers an immediate alert. The water gets declared unsafe, and the public is notified. But here's the thing. These bacterial tests are just the beginning. Beyond bacteria, water quality tests measure chemical contaminants. We're talking about things like lead, which can leach into water from old pipes and plumbing fixtures. Lead is particularly dangerous because it has no taste, no smell, and no color. A child exposed to high lead levels can experience developmental delays and learning problems. That's why the EPA has a strict limit, no more than 15 parts per billion in drinking water. But detecting lead requires sophisticated laboratory analysis. The water sample gets sent to a certified lab where it's heated and analyzed using atomic absorption spectroscopy. It's not a quick test. It can take weeks to get results. That's why many water systems also do visual and corrosion control tests to prevent lead from entering the system in the first place. Now here's something that rarely gets discussed. The testing also checks for organic compounds. These include pesticides, herbicides, and industrial chemicals that may have contaminated groundwater or surface water sources. Some of these substances are carcinogenic. Others disrupt hormones in the human body. The tests use gas chromatography and mass spectrometry. Essentially, the machine separates the chemical compounds and identifies them one by one. A single water sample might be tested for over 100 different organic compounds. If any of them exceed EPA limits, the water utility is required to notify the public and take corrective action. But here's what's fascinating. Different regions test for different things based on their water sources. If your water comes from a river that runs through agricultural land, they test heavily for pesticides.
If it comes from deep groundwater, they focus more on minerals like uranium and radium. Coastal areas test for saltwater intrusion. Rural communities test for nitrates from fertilizer runoff. The testing protocol is customized to the actual risks in that specific area. This means your neighbor 3 states away might not be tested for the same contaminants you are. There's also something called microbial testing that goes beyond just bacteria. Labs look for parasites like Cryptosporidium and Giardia. These aren't bacteria. They're tiny organisms that can survive chlorine treatment and cause serious gastrointestinal illness. Detecting them requires different methods, sometimes even using polymerase chain reaction technology, the same genetic sequencing method used in COVID tests. A single Cryptosporidium outbreak in Milwaukee in 1993 sickened over 400,000 people. That's why modern water systems are obsessed with preventing it. And then there's pH testing and hardness testing. pH tells you how acidic or alkaline the water is. If water is too acidic, it corrodes pipes. If it's too alkaline, it can cause scaling. Water hardness measures dissolved minerals like calcium and magnesium. Hard water isn't necessarily unsafe, but it affects taste, cleaning efficiency, and can damage appliances over time. These daily tests track whether the water chemistry is stable. Here's the part that really gets interesting. Despite all this testing, some contaminants slip through. Emerging contaminants, things like PFOA and PFOS, which are used in nonstick coatings and firefighting foam, are only now being regulated. 10 years ago, they weren't even on the testing list. They were invisible. Some water systems still haven't updated their protocols to test for them. This means there could be chemicals in your water right now that nobody was even looking for 5 years ago. As our science evolves, we keep discovering new things to worry about. But here's what should actually comfort you. The fact that testing happens at all. Every single day, someone is sampling your water supply. Multiple people, multiple labs, multiple methods. If something goes wrong, there's a system in place to catch it. Those daily tests have prevented countless outbreaks and health crises. They've identified contamination before it became a public health emergency. The water you're drinking today has been tested more thoroughly than most foods you eat. So the next time you turn on your tap, remember that what you're about to drink has passed through a gauntlet of scientific analysis. Bacterial tests, chemical analysis, parasite screening, pH and hardness measurements. Dozens of tests multiple times every day, all designed to make sure that simple act of filling a glass is actually safe. That's the invisible work happening behind every drop of water in your home.